Hi, this is Dr. Hall. We're just going to go through today the end of topic test on chemical changes and electrolysis. So I've got the Seneca window here, and I'm just going to go through trying to get all the right answers. I might make some mistakes. Good afternoon. Okay, what region of the pH scale would a substance that forms H plus be on? So H plus is formed by acids. So acids on the pH scale would be up here, the red end, let's say red. Which substances would be in the purple region? So acids are at the red end, and at the other end are the alkalis, but we've got two answers to give here. So alkalis will certainly be one of them, and the other one is base. So an alkali is just a base that dissolves in water. Okay, so we've got here the oil rig mnemonic, and we're asked to fill in the missing letters. Oxidation is, let's jump to the G. Reduction is gain, oxidation is loss, reduction is gain. This is an example of what type of reaction. So we've got magnesium and copper sulfate producing copper and magnesium sulfate. So the magnesium and copper are really just swapping places. So that is a displacement reaction. What characterizes a more reactive metal? One that has more outer shell electrons, one that forms a positive ion more easily, or a transition metal. So the answer is this one, a metal that forms a positive ion more easily and loses its electrons to form that positive ion. In the following reaction, what is the Na plus ion referred to as? So we have sodium bromide reacting with chlorine to produce sodium chloride and Br2. So here bromine and chlorine are exchanging electrons. Sodium does nothing in the reaction. It's a spectator. So that's called a spectator ion. Which of the following would you observe when adding potassium to water? So we certainly see some sparks. This is the most reactive metal that we use in school for adding to water. So we get some sparks, we get a lilac coloured flame, the metal catches fire. Okay, it actually also melts into a ball, but it's hard to see that. And here is the reaction going with quite a decent sized chunk of potassium. Nice, that's much bigger than we were allowed to use in our school demonstrations. You can see why. Okay, give one reason why carbon is used to extract metals from their oxides. So there's lots of carbon about, it's plentiful and cheap. Let's try cheap. Low cost, and it's abundant. State two metals that would react with dilute acid but not water. So here we're in the reactivity series, somewhere in the region of zinc and iron, and could also have had lead, magnesium, or aluminium. Two metals that would not react with water or a dilute acid. So we're down at the very bottom of the reactivity series with metals like copper, precious metals, silver, gold, and platinum. Very unreactive. What is the concentration of H plus at pH 4 in moles per decimeter cubed? So the pH corresponds to value of a concentration of 10 to the minus something. So pH 4 will be 10 to the minus 4. We have 10 to the minus 4 there. That's 4 times 10 to the minus 4. That's the same. This is actually 10 to the minus 4. 1 times 10 to the minus 4. That's the one I'm going to go for. What are two products when magnesium reacts with hydrochloric acid? So this is a metal plus acid. And metal plus acid gives a salt plus hydrogen. Let's type hydrogen first. And the other product from magnesium and hydrochloric acid will be magnesium chloride. Almost finished, says SpongeBob. Select the options which relate to a weak acid. There are two of these. Hydrogen chloride, and that's hydrochloric acid, that's a strong acid. Not all the acid molecules break up. That's a characteristic of a weak acid. Click that one. That is the characteristic of a strong acid. And this ethanoic acid here, which is the acid in vinegar, is a weak acid. So we'll click that one. In electrolysis, reduction reactions occur at which electrode? So here's an example of the reduction reaction. It is adding electrons to the lead ion. So we want the electrode where there are most negative electrons available, and that electrode will be the negative electrode. And if you remember the mnemonic, panic, positive anode, negative is cathode. So the negative electrode here is the cathode. And there we are, we got everything right in that one. We'll go on and look at 4.4.5. Lily completed electrolysis using a solution of sodium chloride. What's produced at the anode and the cathode in the electrolysis? So at the cathode, so we have, remembering panic, positive anode, negative is cathode. The cathode is negative, so positive ions are going to be attracted to the cathode. So the positive ions available in sodium chloride solution are H plus and Na plus, and it's the least reactive of those that is going to be produced, which is hydrogen. At the anode, so this is a positive electrode, we're going to attract negative ions, and our possible ions are Cl minus and OH minus. So when it's a halogen, halogens always take priority over anything else like oxygen that might be produced. So chlorine gas is what is produced there. Why do you get different products at the anode and cathode during this electrolysis? Compounds in solution form ions. Something charged ions are attracted to the negatively charged electrodes, so it will be positively charged ions are attracted to the negatively charged cathode. And here we've got the opposite one, so we'll say negatively charged ions are attracted to the positively charged, positive anode, negative is cathode, anode. Lily completes another electrolysis of an acidified solution of iron oxide, which produces oxygen gas at the anode and hydrogen gas at the cathode. I think the key thing here is it's an acidified solution. So why is hydrogen gas produced at the cathode rather than iron metal? So we can say here hydrogen ions are present in the solution due to the something being acidified. I'm guessing solution being acidified. Hydrogen gas is produced because something is more something than something. Hydrogen, no. Iron is more reactive than a hydrogen. So the least reactive thing is produced at the anode. Okay, that was the end of that test. Okay, I hope you got something useful out of looking at those answers, and thank you for watching. See you again soon.